Welcome to the Sophistic Bridge Design SOFinar Part 2 of 6. My name is Pretensioning, and today I would like to represent the new prestressing functionality which is now available in SOFI Plus 2014. So we just implemented the prestressing definition in SOFI Plus so that we can use all the functionality and advantages of the graphically input. And so that's our main topic today, and the other topic what we just prepared is that we're just going to show you an alternative model of the frame bridge. And before we will start with that, I just give you just a little explanation to the GoToMeeting software. So you will find a button to display as full screen, and you can type your questions into the box which you may have during the SOFinar. And if you won't get the response during the SOFinar, you will get it afterwards as soon as possible by email. So we're just switching immediately to SOFI Plus so that I can show you the alternative model. But first of all, I just show you the model of the frame bridge of the first SOFinar. So in the first model consists of two girders which bear the loads in longitudinal direction, but we also just have a shell element between the girders so that we just have the correct flexural and shear stiffness. But in this model it was not possible to have a transversal distribution. And if we just go to the alternative model, you can see it looks pretty similar. And we also just have two girders and also a shell element between, but we just also created additional shell elements, and for that we just created also additional secondary axes. So the crucial point is that we can have now with this model a transversal distribution, so loads which has been neglected like the loads on the cantilever can now easily be inserted. And now we can apply directly the loads like area loads on the whole width of the bridge, so that we don't have to recalculate the loads only on the girders in longitudinal direction. So it's just a bit easier now, and but we still have the same aim, so only the girders should be the loads in longitudinal direction, and that's why we just have to define orthotropic behavior for our shell elements. And in this example we're not going to do that in the structural area properties. We will do it in the program AC. So for that we just have to make an export of our system. Then we just go straight ahead to SSD. So that's our frame bridge. Looks the same like the first one, which you just saw in the first SOFinar. So just a little notice, the first SOFinar is available at the Sophistic YouTube channel. So now I would like to insert a new text editor task, and to keep our project we're just going to rename it. So the name will be additional properties, then ortho minus shell elements, for example, and then just going to copy it, and then we'll just go straight ahead to the program ASI, and then we can define the orthotropic behavior. And for our calculation we're just going to use every structure element. That means we're just using every group, and we can do it with GRP minus. So minus means we're using every group, and if we're just using the manual with F1, we just have additional information, or just more information to each of the records. Then we just continue. Now I would like to define the orthotropic behavior. So it's GRP2, and here you can define additional properties for the shell elements. So all the shell elements are in the group 110 10. So first of all, we just have to define the number, the group number, and then we're just turning off the bending stiffness in local X direction, and then we're turning off the membrane stiffness in local X direction, because only the girder should be the loads in longitudinal direction. And we're using the self-weight, which I just defined before in SOFi Plus. And first of all, I would like to show you the effect without the record GIP2. And then I'm just going to run it. And if we just go to the animator, just using the self-weight and just freezing the deformation, and just click on quad, you can see that we still have stress in X and in Y direction, and then we don't want to have any stress in X direction, so that means we don't want to have any stiffness, and in local X direction of the shell elements. So if we just go back to the teddy, we're just deleting the dollar sign, and then we're just going to calculate the program RZ again. And if we just go back to the animator, you can see that the quads hasn't got any stresses more in local X direction, so that means we don't have any stiffness in the shell elements in local X direction. Okay, and if you just use the program RZ, so the GRP2 command to define the orthotropic behavior, you can do later on also the design of the shell elements with it. Okay, great. So I would like to switch now to the main topic of the SOFinar, so the pre-stressing functionality. And first of all, I would like to point out that the Sophistic software offers you the great option to define tendons which can be pre-tensioned and bounded, or post-tensioned and bounded or unbounded. And you also can create tendons which can be external to the structure, with points of contact occurring at deviators and anchorages. And all of these options are available for beams and shell elements. So in this SOFinar, I'm just going to show you at 2 examples the pre-stressing functionality of SOFi Plus. So we are starting at first with the CSM example, and this graphically input is just based on a text input example which you could find in Teddy, then File, then Examples, then CSM English, Design, and then CSM_P_1 and so on. So that's the example, and what we're just going to use now in SOFi Plus and SSD. So this example, we just have 2 prefabricated beam girders, and I just prepared everything till the defining of the of the tendon of the first prefabricated girder, and also the parabolic, so the post-tensioning system. And if we just want to give you an overview, so if we just go to the cross-section editor, you can see the cross-section. So it's just a T-beam with a single reinforcement bars and also boundary above. And so this boundary above is just in situ concrete, which will be used in the construction stage number 14, just to connect the 2 prefabricated girders. And I'll just give you just more details later on in SSD and in the next SOFinar. So the topic of the next SOFinar will be the construction stage manager. So then we just close also the cross-section editor, and then we're just starting with the pre-stressing definition. And before we can start with defining the tendons, we just have to define at first the pre-stressing system. So you can find in the System tab the Prestressing Systems, and if you just make a right click on it, you can define the Prestressing System according to your company, to the code like DIN or European Technical Approval, group, and also the tendons, so the thickness of the tendon. And you can see that these fields are automatically be filled. It just depends on what settings you just used. And you just can see that we have here the 0.1% proof stress of pre-stressing steel value, and here the characteristic tensile strength of pre-stressing, and also the pre-stressing force and area number of strands. And if we just go to the second tab, you can see that we have here values, for example, for slip at active anchor, and also wobble coefficient and friction coefficient. And these settings are responsible for the immediate losses, and so it will influence, of course, the pre-stressing result. And we just offer you the option also define your own user-defined pre-stressing system. So if we just go to company, you can define a user-defined one, and now you are free also to change the values like the tensile strength or the maximum pre-stressing force. And also at the second tab you are free to change the values. And so the immediate losses like friction and slip will be taken into account with the program tendon. The long-term losses like shrinkage, creep and relaxation will be calculated with the program AQB and AZ. So in the next SOFinar we will talk about the long-term losses, and they just can be considered with the program CSM, so Construction Stage Manager. And I already just defined two pre-stressing systems, so one for the pre-tensioning systems or tendons, and then also for the post-tensioning tendons. And now I would like to show you how to define a tendon layout in SOFI Plus. So you can find a pre-stressing tab in our sidebar, and then you just have three options. So since the previous SOFI Plus versions, the user can create tendons for slabs, and these commands are now available in our sidebar. And then you can see that we just have another two options, so you can create tendons now for shell PT in SOFI Plus, and also for beams, and you can use the PT detour or the tendon. So if you use the PT detour, you can create one or more tendons on a single duct, and you also can use the draw tendon command. And if you just use the draw tendon command, you can just convert AutoCAD objects like lines or polylines or splines and arcs, and that's what I'm just going to do in the second example. So first of all, we're just starting with the pre-tensioning system for the first prefabricated girder, and we are using the PT detour. So if you just click on it, you can see immediately in the sidebar what you just have to do. So if you're just going to use the PT detour, you just have to define before a geometry axis, and that's what I just showed you in the first SOFinar. And then you just have to click on the geometry axis, and then immediately the PT detour will be open. And as you can see, we just distinguish between the tendon mode and also the duct mode. And if we just switch to duct, you can see that we just have here the geometry of the duct, and we just have here a default. So the PT detour just offers us a default. So this default just depends on the placements you just have used. So in this case, the axis just has three support placements, which the PT detour automatically recognizes as high points of the geometry. So at the moment we are just in the elevation view, but you also could switch to the plan view. And then you just have three options to change the geometry of the duct. So you can just go into the window of the PT detour and just choose the stations you would like to change. So if you just choose them, then you can just drag them easily where you would like to have them. And you also can see in the table that the values just change automatically. And you also can use the properties of each of the stations. So at the moment we just have two objects, and then you can just easily change the value. So for example, like, just to see just a bit better the effect, so for example 75 centimeters, and then you can see also that the changes automatically will be recognized of the PT detour, from the PT detour. So you can use the PT detour window to change the geometry of the duct, or you can use the properties of each of the stations, but there are also just two other ways. So the third way will be just to use the table, and so first of all we just have here the span stations as a default, and you also could just easily switch for each of the span stations to stations if you want to. So the span stations are just factors, depends on the location of the support placements, and if you would like to work with the real length according to the length of the axis, you can just use the stations. Then we just have here the U value. So the U is responsible for the horizontal distance from the reference axis, and you can see the effect in the plan view, and with the V you can change the vertical distance from the reference axis. And then we just have columns for the horizontal inclination and also for the vertical inclination, and you also can just use a straight line in negative and positive direction, which will look like that. And you also can, just to see the effect just a bit better, you can also just scale the elevation, and now you can see also the values, or the effect of the values, just a bit better. And then you also just have the option to use a horizontal radius or also vertical radius. So that's what I would like to show you too. So if I just use a vertical radius of 9 meters for example, you can see easily the effect in the PT detour. And also you can create a length of the radius or of the curve, which will look like that also. Okay, so for our prefabricated girders, so for the pretensioning tendon, we just need a straight tendon, and only for the first prefabricated girders. That's why we're just going to delete the other stations with delete select command. But you also could draw easily new stations with the draw point command. So if you just click on it, you can just easily draw additional stations, which is in this example not necessary. Okay, then we just have to use a vertical value of 88 centimeters. And we don't need a vertical inclination. Okay, then we just go further to the tendon mode. So now we just have to match the tendon according to the new geometry of the duct, and we also just have to change before the length of the geometry, so it will be 2475 meters. And then I just go back again, and we're also using not the span stations, so we're using the stations just to use the real length, and it will be 24.75 meters, but only with 1 point. And now you can see that we just created a tendon, and you also could easily just create a new tendon and also just more than one tendon for one duct if you want to, with the draw tendon command. And then we just have here the properties of the tendon, and we need a load case, so because the curvature loads will be stored in this load case, which in turn will be stored in our sophistic database. So the program AZ and Star3 and AQB are using this load case for the design. And so we are using the load case number 11 and the pre-stressing number 1, and then we just have here also the option to change the geometry, so you can use just a relative start offset or also just effective real start offset. And then we just have here the construction sequences, so you can just define a stage number for stressing and grouting, which will be 11 and 12, and this will be just needed later on for the construction stage manager, which will be just important or necessary for our next SOFinar. Then we just go further to pre-stressing, and we just have here 3 methods, so you can use according stresses, free pre-stressing, or also manual definition. And for each of the methods you will find additional information in the manual of the program Tendon. So we are using in this example according stresses, and the pre-stressing direction will be from right, but there are also just other options, and the checking procedure will be just tensioning. And we are using a friction safety factor also, and the number of tendons will be 2. And for our pretensioning system we just have to define additional data, so we just need a force transition length of 3 meters, and the kind of progress will be linear on both sides. Then we can define here the maximum force of the tendon, and also the stresses in the tendon immediately after tensioning, which will be needed in this example. So the program Tendon will recognize automatically if the K value is smaller than 10, the program will recognize it as factor, but if the value are bigger than 10, it will be used as stresses, and we are just going to use a stress of 1220 Newton per square millimeters. Okay, so we are just finished with the definition of the first prefabricated tendon, or the pretensioning tendon, and then I just confirm the dialog, and you can see immediately that the tendon is created. And if we just go to the filter, I would like to show you something. You can just turn off the tendon, and we also just have here another line, which is the duct, so the blue line. Okay, then we just go back to the pre-stressing tab, and now we're just creating the post-tensioning system, and this tendon will be pre-stressed after hardening of the in-situ concrete, what we will see later on. So I'm using also the PT detour, and then I just click on the axis, and I just go straight ahead to edit duct, and then I would like to show you the fourth possibility which you have to define the geometry of the duct. So if I just go to my files, prestressing, and then I just prepared a Excel sheet, and you just have the option to define the geometry by just pasting the Excel sheet, for example, into the PT detail what I would like to demonstrate. So if I just copy it, the values or the table, and just go back to SOFi Plus, which will be this example, and then I just going to use the stations, and then I just paste the Excel sheet into the PT to editor with Control and plus V. And now you can see that we just easily created a geometry duct just in using our X table. And you also just have the option with a right click to insert new rows, and you also could just delete them very easy. Then we just go to the tendon mode, and we don't have to change here something, but we just have to change the properties. So we're just using the Prestressing System 51, Then we are using the construction stage number 51 for stressing and 52 for grouting. And we're also using grouting stresses, but this time from right and then left, so the pre-stressing direction will be from right and then left, sorry. Then we're using the checking procedure tensioning plus slip, and we're using just one tendon. And we're also just defining the stress in the tendon immediately after tensioning with 1220 Newton per square millimeters. And then I just confirm the dialog again, and you can see that we just created a parabolic tendon. Okay, so in SOFi plus 2014 it's also possible just to clone tendons, but it's just important and necessary that you just use the PT detour before. And now we just could clone the parabolic tendon, for example, and then we just have to insert the U and the V offset, and I'm just going to demonstrate it. So we're just using a U offset, and now you can see that we just created a clone of the parabolic tendon with the same settings and properties. And you also just could change afterwards also the clone parameters if you want to. But for our example, we are not using a clone. And then we're just going to make an export. Okay, so these are the prefabricated girders, so at the moment they are connected, and we are using the construction stage manager just to create each construction stages. And I don't want to go into details because this is going to be our next topic in the next SOFinar. But you can see that the program is just doing a lot of calculation. And then I would like to show you the effect in the animator. So at the moment we're just starting with the pre-stressing, and we're using a value for the amplitude of 100, and we're using also the freezing button. And so we're just starting with the pre-stressing, and then we just go further to the fabrication, so additional self-weight. Then we just have the creep of each of the fabricated girders, and you also can see that they are not connected. And we're also just using the temporary supports also, which will be replaced later on by final supports, what I'm going to show you now. Then we just have the creep afterwards, and then the next stage will be the in situ liquid concrete, so additional self-weight. And in the construction stage number 40 we just have the hardening of the in situ concrete, and then we just have the connection between the prefabricated girders, as you can see it here. So I just repeat it again. And now the prefabricated girders are connected. And then we just go further. Then the temporary supports will be replaced by the final supports. And then we just have here the pre-stressing of the parabolic tendon. And in our next SOFinar you will get more details for each of the stations, and also we're just going into the details of the results. Okay, now I would like to switch to the second example, just to show you the draw tendon command, and that's why we're just going to open the other example. This is just an example of the first SOFinar. And So yeah, no tendons are defined. And now I would like to show you the tendon draw command. And you can see that I already just defined some splines which should be the tendons. So if you just click on the tendon command, you just have two options. So you can just use just structure lines, so it's not necessary to define an axis like for the PT detour. You also just could use just a simple structure line, and then you just have to click on the axis or the structure line, and or then you just have to enter or just confirm the selection. And if I just do that, you can see that we have here the properties of the tendons, and then we just have to define the properties at first of the tendon. So we are using the Prestressing System, then we are using the stage number stressing 11 and for grouting 12, and the prestressing direction will be from left, and we're using tensioning and slip as checking procedure, and the number of tendons will be 2. And we also just would like to define the maximum force of tendon and also the stress in the tendon immediately after tensioning, and we are using the factors from the Eurocode number 2, which will be the K values. And then the K7 and the K8 factor. And then I just make a right click in the AutoCAD window, and then I just have to select the splines, or for example also arcs and lines. And now we just easily created the tendons with the draw tendon command, and we also just have to do it for the other side. And then I just select the splines again. Okay, so we just created very quick the tendons for our frame bridge, and then I would like to make an export to SSD. And then I would like to make the analysis. So first of all the self weight, and then we just have here the pre-stressing load case, which will look like that. Okay, and what I also would like to show you, you will find in the resolve viewer the results of the tendon for the beam and the shell elements. So if you just click on it, the program tendon just creates automatically the results of it, and you can see here easily that we just have here the duct, and in the middle of it we just have the tendon, and here we just have the pre-stressing results. And what is also just important, we just have here the pre-stressing systems, where you can find all the necessary information which is be important for your project. Okay, so now we're just finished with the second SOFinar, and I hope you just enjoyed it, and I just would like to make some commercial, if you don't mind. So you will find a schedule for the next SOFinars on our homepage, so sophistic.com /support/training, and we will be just very pleased if you just would join us again. And yeah, so that's it. Thank you for your attention, and bye.